Alright, in this video we're going to talk about symmetry of functions, symmetry with respect to the x-axis, with respect to the y-axis, and with respect to the origin. We're also going to determine whether a function is considered an even or an odd function. The first thing we want to talk about is symmetry. Symmetry with respect to either the x-axis, y-axis, or the origin. If you can replace your equation, if you can replace your y with negative y and the equation become unchanged at all, then it has symmetry with respect to the x-axis. So something like this, where the top matches the bottom above the x-axis matches below the x-axis. If you can replace x with negative x and your equation remain unchanged, it has symmetry with respect to the y-axis. So notice what's on the left side matches what's on the right across the y-axis. And symmetry with respect to the origin is when we replace the x with negative x and the y with negative y, and our equation remains unchanged. So you might recognize this as the cubic function, y equals x cubed. This kind of looks like the squaring function, y equals x squared, some type of variation of that graph. This is an oval or a circular function. So let's just do a couple of these tests to determine whether an equation or a function has symmetry with respect to the x, y-axis, or the origin. So without graphing, determine whether the equation has a graph that is symmetric with respect to the x-axis, the y-axis, the origin, or none of these. So in this case, first let's try the test about the x-axis. If I replace y with negative y, does my equation go unchanged? So if I do that, that did change my equation. This is not the same thing. If you wanted to solve for y, you'd have to change all the signs of everything. Therefore, my equation would be changed. It would not remain unchanged. So there is no with respect to just the x-axis. So let's erase that. If we replace x with negative x, let's see what happens. In this case, I think we're going to have an issue here. I think it'll work. So 2 negative x, if you raise that to the fourth power, the negative 1 to the fourth will become positive 1. So we'll just get positive x to the fourth. So notice my equation remained unchanged. So we definitely have symmetry with respect to the y-axis going on. Now if I try to do it with both changes, let's see what happens if we try to change both variables. Negative y notice that my equation is going to be changed. We're back to the same place we were earlier, where we did not, it didn't work. Your equation is different than your original. So it doesn't have symmetry with respect to the origin. So in this problem, we would say that the graph of y equals 2x to the fourth minus 3 has symmetry with respect to the y-axis only. Let's try another one. Y equals x cubed minus x. So first let's try to replace the y with a negative y and see if that changes our equation. And as you can tell, it does change the equation, because if I were to get the y by itself, I'd have to change the signs of everything, and that would not be the same equation at all. So with respect to just the x-axis is out of the question in this problem. Let's try the test for symmetry with respect to the y-axis. So on this one, we're going to replace x with negative x. Okay, so y would equal a negative 1 raised to the third power would remain negative 1. So negative x cubed, and then that would be plus x. Notice this is not the same equation as your original, so it has been changed. Therefore, it doesn't have symmetry with respect to just the y-axis either. So let's test for symmetry with respect to the origin. Now, if we do that, it says we have to replace y with negative y. So let's do that. And x with negative x. So let's see if that will work. So I have negative y equal to, this would be negative x cubed plus x. So then if I wanted to get y by itself, I would just multiply through by negative 1. So y would equal x cubed minus x. And if you notice, when I did that, my equation remained unchanged. Therefore, we can say that this equation, or this function, has symmetry with respect to the origin. Because replacing y with negative y and x with negative x caused no change in the original function. Now, if you want to classify a function as either an even or an odd function, a function is an even function if you replace x with negative x and you'd have no change. In other words, if your graph is symmetric with respect to the y-axis, it's also an even function. A function is odd if you can replace x with negative x and replace y with negative y. It would be an odd function, or if it has symmetry with respect to the origin, it's considered an odd function. So we kind of already know this, we just didn't know to call it even or odd. So let's do a little test on a couple of problems here to see if we can classify the function as being an even or an odd function. Determine whether each function is even, odd, or neither. So f of x equals x to the fifth minus 2x to the third. So first what I would do is the little test for evenness. So if I replace x with negative x, if I don't change the equation, then that would be true. So negative x to the fifth minus 2 times negative x to the third. Well, we know that negative 1 to the odd power of 5, or to any odd power, would stay negative. So we would get negative x to the fifth plus 2x to the third, which is totally different than our original function. So this is not going to be considered an even function at all. Now let's try the odd function. Now, to see if a function is odd, it's had to have symmetry with respect to the origin, which means we have to change the y to negative y. So let's do that. Negative f of x. And then we have to change the x's to negative x's. So let's see what we get here. Negative x to the fifth minus 2 times negative x to the third. So negative f of x, that would remain negative x to the fifth. And this would be plus 2x to the third, because you'd have negative x to the third times negative 2, which makes positive. But now that we have the negative in front of the f of x, if I distribute that negative, or in other words, divide through by negative 1, look what we have. We have the same thing we had originally. So since this function has symmetry with respect to the origin, we also can classify this as an odd function. Let's try one more. F of x equals x to the fourth minus 5x plus 8. So we have a bigger equation here, but we can still use those same properties to determine whether or not it's even, odd, or neither. So the first test we want to check is just replacing x with negative x. So let's try that. Okay, so if I have negative x to the fourth, that's going to make it positive. So x to the fourth, that won't change anything. But if you can tell here, that's going to be plus 5x plus 8. So there's a big difference between your original function and your new one. So we know the function is not even let's do the test for oddness and see if that works. So we're going to negate y, so negative f of x, negative x to the fourth, okay, so I get negative f of x, that makes positive x to the fourth, plus 5x, plus 8. Now, if I have a negative function, I need to divide through by negative 1 or multiply through by negative 1 to clear that out. So f of x equals negative x to the fourth. I'm already in trouble. So that doesn't work either, because notice my original has positive x to the fourth. So it's not odd. So we would say that this function is neither even nor odd. It's neither. It's neither even nor odd.